Coming back to problem number 4. Okay, so once again, we're looking for our applied force. We see that applied force is over here in this equation. All right, so let's just do this. We're just going to drop down our applied force minus our Fk. Are we given that? No, we don't have our Fk. Okay, but we do have our mu k. All right, and we know that Fk, I'm just going to write this over here. We know that Fk is equal to mu k times Fn. All right, so Fk is equal to mu k, which is 0.2, times our Fn. Well, we don't have Fn over here, but we do know that we have Fn over here. So we have Fn minus our Fgy. We don't have Fgy over here, but we do have Fgy over here. Okay, so what I'm just going to do is I'm just going to scroll down a little bit and let's just redraw our triangle down over here. Okay, so we have our Fgy, which is what we're interested in. And then we have our Fgx and Fg. 32 degrees and a right angle. Okay, so we want to get our Fgy. Well, do we have our Fg or any other parts of this triangle? No, so we do need this. And how do we get our Fgy? Well, we have our mass over here, so therefore we could find out what Fgy is equal to. Okay. Okay, and so we have this one part of the triangle, and we have our angle, so therefore, using trigonometry, we could find out what Fgy is equal to. First thing to do in trigonometry is identify the different parts of the triangle. So, what does the Fg represent? Hopefully you're saying to yourself, that's our hypotenuse. And what about the Fgx? That's our opposite, and Fgy is our adjacent. Okay, and now which trig function do we want to use to find out what our Fgy is equal to? All right, so once again, we're dealing with our adjacent and our hypotenuse, considering that we do have this value over here. And what trig function has to do with both adjacent and hypotenuse? Hopefully you're saying to yourself, the cosine function. All we have to do is multiply 637 to both sides of the equation and we'll get our answer. Once again, keeping in mind the idea that our calculators do need to be in degree mode, not radian mode. And we get 540 newtons. Okay, so that's what our Fgy is equal to. Now, once again, why did we get our Fgy? Well, so we got this, so we could plug it into here. And we could we could find out where our Fn is equal to. And get that in here, and that's where our Fk is equal to. So we could plug that into here and find out what our applied force is equal to. Wow. Okay. So Fgy is equal to 540. And our Fn is equal to 540 newtons. So therefore, our Fk is equal to 108 newtons. And that's what we're going to be plugging in for here. Minus our Fgx. Oh, so once again, we don't have our Fgx, but we do have Fgx down over here, which is our opposite side. And our opposite and hypotenuse, the hypotenuse is what's given, so therefore, which trig function do we want to use to find out what the opposite side is, the Fgx? Dealing with opposite and hypotenuse, which one of these? Hopefully you're saying to yourself the sine function. multiply 637 to both sides of the equation, and we'll get our answer for that. So we have 337.6 newtons. You know what? Just to keep things not so bunched up over here, I think I'm just going to round this to 338 newtons. And that's really just because I don't want to be having this so bunched up over here. It's already getting a little crammed, and I understand that. So 338 newtons is equal to our mass times our acceleration in the x direction. Look at that, and we're pretty much ready to go to solve this out. I'm just going to do this all in one step. Adding 446 to both sides of the equation, we'll get 901 newtons. And that is our final answer. Hopefully we got it correct. Crossing my fingers here. No, we didn't. Okay, so I'm actually just noticing right now that I used the degrees for the previous problem. This is 32 degrees. I actually just used the 32 degrees over here. And it should actually just be 25 degrees. And that's the reason why I got my problem wrong. And what I'd like for you to do is do this problem again and try it out with the 25 degrees, which is the correct degree angle, as opposed to the 32. And I could actually just imagine here, if I use if I use 25 degrees here as opposed to 32, I would have gotten the correct answer. This is in the ballpark of the correct answer, and I'd imagine that this is the only error I've made here. I apologize for that. That's very sloppy of me to do. I understand that, but I'd like to actually challenge you to try this out by yourself using the correct degrees and seeing the answer that you get.